In this video, we're going to look at various quadratic application questions, but this time you're not going to be given an equation, so you're going to have to come up with one on your own. So there are various types of questions. Some are related to integers, some are area and rectangle, some are revenue. So we're going to look at some common ones and we're going to set them up and solve. And just like the application questions where you were given the equation, you're either going to solve the quadratic equation by factoring, or you're going to have to solve for that maximum or minimum value by completing the square or averaging the zeros. So the only new part to this lesson is setting up that original quadratic equation. And then it should be familiar if you know what you need to find. So let's start this off. Two numbers have a sum of 21. Their product is 68. What are the numbers? The question that is given to you, that final few words, what are the numbers? Those tell you what your let statements should be. We have two numbers and our goal is to figure out what they are. So your let statements will be let x represent first number, and then let y represent second number. And you always have to start with your let statements. Not only is it good organization for you so that you remember what your goal is and what the variables represent, but it's important for your good communication. Okay, now we had two statements here that will give us two potential equations. One is that the sum is 21. So if I add x and y, I should get 21. So x plus y is 21. This by no means is quadratic because we don't see an exponent of 2 anywhere. So this right here is actually going to be a little side note equation that is going to be important later on. And what we're going to do with this equation is isolate for one of your variables, either x or y, and then we're going to do a substitution into a second equation. So let's just go ahead. If you have something that looks linear, isolate for a variable. So I'm just going to isolate for y, which means I'm going to bring x to the other side. So y is equal to 21 minus x, and I'm going to keep that on the side for now. Let's go to the next statement that I highlighted. The product is 68. Product means multiplication. So if I multiply x and y, I'm going to get 68. So x times y, or xy, equals 68. This still doesn't look quadratic, but I do have multiplication. So I'm going to do a mini substitution here. I know that y is equivalent to 21 minus x. So instead of writing y in my product equation, I'm just going to swap it out. So I'm going to write x, and then in brackets, instead of y, I'm going to write what it's equivalent to, which is 21 minus x. Now this is quadratic because the minute I distribute that x in, I'm going to get an x squared. So problem solved. So this right here is your quadratic equation, and my goal is to figure out my numbers, so I need to solve this equation and solve for x. Now, I know to solve a quadratic equation, it should be in standard form and one side should be equal to 0. So the first thing I'm going to do is deal with these brackets, and I'm going to distribute that x in. So that when I do x times 21, I have 21x, and x times negative x is negative x squared. Now I know the second criteria is that one side should be equal to 0, which it isn't, and I have the choice to either bring the 68 to the left or bring these two terms to the right. Now, typically I would just bring the 68 to the left, but I noticed that my x squared coefficient is -1. And if it were +1, it would be a simple trinomial and I could quickly factor. So I'm actually going to bring the x squared to the right, and same with the 21x. And that will still give me 0 on one side. And when I bring it over, I'm going to make sure I go in the correct standard form. My x squared first, then -21x, and the 68 at the end. Now I have a nice simple trinomial. There's no common factor I have to worry about. So I'm just going to find my magic numbers. I need two numbers that multiply to 68, but they add up to -21. So when you play around with your numbers, you should get -4 and negative 17 as those magic numbers. So 0 equals x minus 4 and x minus 17. So then I can branch out, which I'm going to do up here, and I have x minus 4, that is equal to 0, so that x equals 4, and x minus 17 equals 0, so that x equals 17. Now remember, if you look at your let statements, x represents the first number. This does not necessarily mean that your two numbers are 4 and 17. These are different options. So sometimes with these quadratic equations, because you do solve for two intercepts, you might have actually two different options for the same scenario. So option 1 is that your first number is 4. So if my first number is 4, to figure out my second number, I go into this y equals 21 minus x equation. So y equals 21 minus 4, and it's equal to 17. And if I do it in option 2, y equals 21 minus 17, which is 4. So in this scenario, actually, they are the same option, but you still have to test it out. So at the end, make sure, therefore, the numbers are 4 and 17. And then you can do a quick logic check. 4 plus 17 is 21. So that first criteria is checked off. 4 times 17 is 68. So perfect. I feel confident and I can move on. Now, for the next problem, we're just going to set it up. We're not going to worry about solving it because the solving is the exact same like above. So, two consecutive numbers have a product of 728. So that's important. What are the numbers? Okay, so in this scenario, they didn't tell us anything about a sum or a difference to have a side note, but they did tell us that the numbers are consecutive, which means like 2, 3, 10, 11, 20, 21. Now, when you have consecutive numbers, so let me just put that example, maybe 3 and 4, to get from one number to the other, I'm just adding 1. So if my first number is x, if I add on 1, x plus 1 would be my next number. And that's what makes them consecutive because they're 1 unit apart. So in this scenario, my let statement doesn't have to have two different variables. They can actually both be in terms of x. So let x represent first number and let x plus 1 represent the second number. And this is because they're consecutive. If they had been consecutive even or consecutive odd numbers, you're skipping the middle number, so it'd actually be x plus 2 for the consecutive even or odd number. Now it says that the product is 728. So if I multiply x and x plus 1, I'm going to get 728. And this here is your quadratic equation, and then you would be solving it, which means, again, you distribute everything into your brackets, bring the 728 over, and then you'd have the quadratic equation ready to go. So maybe let's prepare it. So I'm going to bring the x in, and I'm going to bring the 728 all at once. So x squared plus 1x minus 728, because we're bringing it over the equal sign. So this equation right here is ready to go. You would just factor and branch out like we did above. But we're just setting it up, so this is perfect. Now, let's try a different type of example, and here we're going to look at rectangles and area. The length of a rectangle is 3 centimeters more than the width. This seems important, so I'm going to highlight it. The area of the rectangle is 119 centimeters square. What are the dimensions of the rectangle? So I know I need to find length and width, so those would be my let statements. But I do have a nice statement here where it says that the length is 3 more than double the width. So because the length is given in terms of the width, I'm going to say let x represent my width. And for my length, I'm not going to say y, because I know that if I double the width, which means multiply by 2, and then add 3, I will get my length. So doubling the width would be 2x, and then I want to be 3 more, so I'm gonna add 3. So 2x plus 3 represents the length. And I don't have two variables, so that's wonderful. Now it tells us that the area is 119, and I know that the area of a rectangle is length times width. So I know my length is 2x plus 3, and I know my width is x. So if I put those together, I should get 119. So x times 2x plus 3 equals the area of 119. I'm looking for x, I need to solve for it. So now it's the exact same steps as the previous scenario. So I'm going to distribute my x in, and while I'm at it, I'm also going to bring that 119 over, so that I get x times 2x is 2x squared, x times 3 is 3x, and when I bring that 119 over, I am subtracting because I have to change the sign. Now, in this scenario, it is no longer a simple trinomial because of this 2 in front of the x squared. So I have to do decomposition here. I can't do the shortcut. So I need to multiply 2 and negative 119. So I need to find two numbers that have a product of negative 238, but the sum has to be positive 3. So I know my two numbers, one should be positive, one should be negative, and the bigger number should probably be the positive one. So when you play around and you try on your calculator, I would do 238 and start dividing it by different numbers. Now, if you do 238 divided by 17, you get 14. So if I make my 14 negative, problem solved. So 17 and negative 4 are my magic numbers. So I'm going to decompose that 3x into those two numbers. So 2x squared plus 17x minus 4x minus 14x equals 0. Now I'm going to pair them up and find the common factor in each pair. So between 2x squared and 17x, my only common factor is x. So I'm left with 2x plus 17. And between negative 14x and negative 119, I can actually factor out a negative 7. And the negative is important because the first term in that pair was negative. So then I'm left with 2x plus 17 again. And now, one of my brackets will be that common 2x plus 17, and the other will be made from the leftovers in front, which is the x minus 7. Now that we factored, we can branch off and set each of our brackets equal to 0. So 2x plus 17 equals 0, or x minus 7 equals 0. When I solve the first one and I bring the 17 over, it becomes negative, and then I divide both sides by 2, and I get negative 17 over 2. I can't have a negative dimension because I know x represented the width, and you can't have a negative width. So this right here, we say is inadmissible. Because you cannot have a negative width. So that's out. We don't have to worry about that option. But when I go to my other bracket, so the x minus 7, and I bring the negative 7 over, I get x equals 7. And that makes sense for the width. So if this is my width, I go back to my let statement and I see 2x plus 3 would be my length. So for my length, 2 times 7 plus 3. So 2 times 7 is 14. And when I add on 3, I get 17. So there are my dimensions, 7 and 17. So therefore, the rectangle is 7 centimeters by 17 centimeters. And then you can do a quick check and do 7 times 17, and you get 119, so you know you've done it correctly. All right, let's try to set up another rectangle area scenario. Now this one's slightly different, and a diagram will be very important to us. So an 8 meter by 5 meter rectangle is surrounded by a uniform border on all 4 sides. So I know the original rectangle and I know there's a uniform border, kind of like a picture frame. The area of the new rectangle is 100 meters squared. Find the width. And by the width, they mean the width of the uniform border. So I'm going to start off with a little diagram. So let's say this is my original rectangle. It is 5 meters by 8 meters. But then there is a border around it. And in this border, the width on each side is the exact same. And my goal is to find that width. So why don't we just make the width be x? So once I put that in my diagram, I'll put it in my let statements as well. Let x represent width of border. Now I know that the new area of this rectangle, so this whole thing, is 100 meters square. And I know that the area of a rectangle is length times width. I know the original length and width, but I know that those dimensions have been extended by x on each side. So if I can just come up with a new expression for the length and width, then I can set up my equation right away. So let's start with this length here. This length used to be 8, but then I add x on top and x on the bottom. So I have added 2 x's to 8. So 8 plus 2x would be my new length. And then for my width, it was originally 5 meters, but then I add x on the right and x on the left, so I have added 2 x's in total. So 5 plus 2x would be my new width. And now that I have an expression for length and width, I can put it together into my area formula, and I will set it equal to 100 because that's what the area is equal to. So new length, 8 plus 2x times new width, 5 plus 2x, is equal to the area of 100. And I know that my goal is to solve for x so that I find the border, which means I need to turn this into standard form and have one side equal to 0. So let's just get this ready to go, and then we'll go to the next one because we don't actually have to solve it because that part's repetitive. So I'm going to do some FOIL here, and I'm also going to bring the 100 to the other side. So 8 times 5, 40. 8 times 2x, 16x. 2x times 5, 10x. And 2x times 2x, 4x squared. When I bring the 100 over, it becomes negative. And now all I'm going to do is collect some like terms and get it in that right order. So the 4x squared will go first. The 16x and the 10x add up to 26x. And then the 40 with the negative 10 give me negative 60. Now I have my equation ready to go. All I have to do from here is factor. I'd probably do a common factor and then decomposition. And once I factor it, I can branch out and solve like above. So I just wanted to show you another potential question and how to set it up. Now, all 4 of these questions that we've done, they were find the dimensions, find the width, find the numbers. So you were solving a quadratic equation. Nowhere did you see the word maximum or minimum. But in the next ones, you will see maximum and minimum, which means for the next ones, we are solving for the vertex. So we're not solving a quadratic equation anymore. And as a reminder, to find the vertex, you can either average the zeros if they're easy to find, or complete the square. So let's look at the first one. You have 12 meters of fence for a rectangular area. So that 12 meters, if I just draw a quick diagram of a rectangle, let's say this is the rectangular area, that 12 meters, because it's covering all 4 sides, that's your perimeter. So I'm going to put P for perimeter. What are the dimensions of the maximum area you can enclose? So because I mentioned the dimensions, I know I need X and Y for length and width, and they don't give me any relationship between length and width. So my let statements will just be let X represent length, and then let Y represent width. And I'm just going to go to my diagram. I'm going to label my lengths and I'm going to label my widths. And if I add all 4 of those sides together, I'm going to get that 12 meters of fencing. So 2 x's and 2 y's add up to 12. Now this is clearly not quadratic. It's like that first example we did. It's a linear relation, which means this is probably going to be that side note piece of information where we need to isolate for a variable. And again, the choice is yours. I'm just going to isolate for the y. So I'm going to bring the 2x over so that I have 12 minus 2x, and then I'm going to divide everything by 2, which means I get y equals 6 minus x. So that's going to be important later on. Now my goal is to maximize the area, which means I need to find an area equation. And I don't know what that area is, so I'm just going to add another variable here. Let A represent area, because I'm about to write A equals length times width. So A equals x times y. Now I see the multiplication, which makes me think, okay, this is probably going to be quadratic, but I have too many variables. So instead of writing y, I'm going to write the 6x, or the 6 minus x, because that's what y is equivalent to. So I'm going to do a little substitution here so that I get area equals x times 6 minus x. Now it's quadratic. I also notice that this equation here is already factored. There's a common factor of x, and then I have my bracket. So I personally would do averaging the zeros because it's super quick for me to find the zeros here. I'll set my area equal to 0 because that's important for finding the x-intercepts. Quickly branch off because it's ready to go. It's already factored. And then I'll average my values. You can also choose to distribute the x in to get it into standard form and then complete the square. That would just be a bit more tedious. So, important here that you set your area equal to 0, just like when you're solving for your zeros in regular knowledge questions. And now we branch off. X equals 0 or 6 minus x equals 0. I'm just going to bring the x over so that it becomes positive. And here we are. These are your zeros. So don't accidentally say, oh, I can't have a length of 0, so my answer is 6. No, we need the vertex. So I need to take both of these values, even if one had been negative. I'm going to add them and divide by 2 so that I get 6 over 2, which is 3. Now this was the x coordinate, and x was length. So my length for my maximum is 3. Now if I take this 3 and I plug it into this area equation, I'm just going to get the maximum area. But it didn't ask me about the maximum area. It just asked me for the dimensions to get the maximum. So now that I know what my length is, I can sub 3 into my y equals 6 minus x, and that will give me my width. So y equals 6 minus 3, which is 3. And there's my width. And if I multiply 3 times 3, I get 9. And we know that for a regular rectangle, the maximum area occurs when you have a square, and we just showed it algebraically. And you would have to show this algebraically even if you have an idea in your head of what the dimensions should be. So therefore, a 3 meter by 3 meter rectangle will have a max area. All right, let's try another one that is very similar, except there's a little twist on this rectangle. So a rectangular garden is to be divided into 3 sections. We haven't seen that before, so our diagram will show those 3 sections. If there are 24 meters of fencing available, so that's the perimeter again, what dimensions will result in a maximum area? So, super important that you start with your diagram. And I need this garden to have 3 sections. So here we are. My let statements will still be the same. Let x represent length. Let y represent my width. But now, when I go to label my rectangle, I have two lengths here that span the entire garden. But then for my widths, I don't only have the two outside widths, I also have the dividers in the middle, because those need fencing as well in order for you to have 3 sections. So that 24 meters of fencing isn't only for 2 X's and 2 Y's, it's for 2 X's and 4 Y's. And that's why this diagram is very important to have, because I can create that sub-equation. 2x plus 4y's is equal to 24. Now, when I choose which variable I want to isolate for, I want to choose the variable that will not result in a decimal. So if I were to isolate for y like I normally have been doing, I'd have to divide everything by 4. And if I do 2 divided by 4, it's not terrible, it's 0.5. But if I chose to isolate for x, I can divide 4 and 24 by 2, no problem, and my numbers would all be nice and whole. So I'm personally going to isolate for x in this scenario. So 2x equals 24 minus 4y. And when I divide everything by 2, I get 12 minus 2y. And now I'm maximizing my area, so I'm going to say let A represent area. And normally, area is length times width, so x times y. But I'm going to replace x with what x is equal to. And here, I personally like having my bracket in the second spot. So when I write my area, I'll write y times 12 minus 2y. And then this is ready to go now. And it's factored once again, because we have two things being multiplied. There's nothing on the outside. So I would average the zeros from here. All right, let's try another setup. And this one is with integers. The difference between two numbers is 8. Find the numbers if their product is a minimum. I see the word minimum, I'm thinking of the vertex again. So my goal is to find the numbers. So my let statements will be let x represent the first number, let y represent the second number, and my goal is to find a minimum product. So I'm just going to write let p represent product, because I'll probably have to set up an equation for product, and I don't know what the product is. Now, let's see that first statement I highlighted. The difference between two numbers is 8. So if I subtract x and y, so x minus y, I get 8. This is clearly not quadratic, so I'm going to isolate for a variable, and I choose to isolate for x because its coefficient is positive 1. So x equals 8 plus y. If you chose to isolate for y and you brought the x over, you'd have negative y equals 8 minus x, so you'd have to divide everything by that negative 1. Okay, now let's use that product information. The product is a minimum. So P for product means I'd be multiplying x and y. It's almost quadratic. I just have to replace x with 8 plus y. So my product is y times 8 plus y. Now this is ready to go. The word minimum was there, so I need to find the vertex. And here I personally would average the zeros, just like I did in the previous example. So I'd set p equal to 0 and branch off. But again, you could also distribute that y in and complete the square. They will both take you to the same place. All right. Let's try our last example, which is a revenue example, and this is very common. So, calculators are sold to students for $20 each. 300 students are willing to buy them at that price. For every $5 increase in price, there are 30 fewer students willing to buy the calculator. What selling price will produce the maximum revenue, and what will the maximum revenue be? So I need to know the selling price, and I need to know what that maximum revenue is. Now, for these types of scenarios with revenue, your price and the number of students that are willing to buy this calculator depends on how many times you want to increase the price. So before we get into the let statements, the revenue means how much money is being made or how much money is coming in. So it's going to depend on the price times the number of students or the number of sales. And it will always be that price times number of sales. So the price depends on how many times I'm going to increase it, and the number of students depends on how many times I'm going to increase the price. The original price is $20, and the original number of students is 300. But each time I increase the price will go up by $5, and the number of students will go down by 30. And this all depends on how many times I want to increase. So let X represent number of price increases. And this will always be the let statement. For these types of revenue questions, X will never represent the price or the number of sales or anything like that. It will always be the number of price increases. And then I'm also dealing with revenue, so I'll just say let R represent revenue. So R is equal to, I need a bracket that will represent my price, and I need a bracket that will represent the number of students. I know the original price is 20. If I increase the price one time, my new price will be 20 plus 5. If I increase the price 2 times, my new price will be 20 plus 10, because 5 times 2 is 10. So if I increase the price X times, the price increase will be 5 times X. So the new price will be 20 plus 5X. The number of students is originally 30. If I decrease the price once, I'm going to subtract 30. If I decrease the price twice, I'm going to subtract 60. If I decrease the price X times, I'm going to subtract 30X. So each bracket forms its own little linear equation. The number in front of X is the rate of change, like $5 per price increase, 30 students per price increase. And then 20 and 300 is that initial amount. And here is my quadratic equation. And again, it's nicely factored for us. So I would branch off and find my zeros and then average them. But before you do that, you must set R equal to 0. So when I branch, 20 plus 5x can equal 0. When I bring the 20 over, it is negative. Divide both sides by 5, and x equals negative 4. Then I do the same on the other side. Set my bracket equal to 0. Bring the 300 over, it's negative. And then I'm dividing both sides by negative 30, which gives me 10. I don't cancel any of these options out. And remember, these are your zeros. These are not your answers. I need to average them. So I add the negative 4 with the 10 to divide it by 2. And when I add them, I get 6, and 6 divided by 2 is 3. And x represented the number of price increases. So there are 3 price increases. So if I need to find my price, the selling price, I know that the price equation is 20 plus 5x. So instead of x, I'm going to put 3. So 20 plus 15, $35 per calculator. And that would be the price. If I wanted to find the number of students, I would plug it into the second bracket. But the other part of the question was to actually find the revenue. So 20 plus 5 times 3, 300 minus 30 times 3. And I simplify each bracket at a time. So 20 plus 15 is 35, there's that price. 300 minus 90 is 210, so that would be the number of students or the number of sales. And now when I multiply these two numbers, I get $7,350 for that maximum revenue. Therefore, the max revenue of $7,350 occurs when calculators are sold for $35. And there we are. So look out for the word max or min to know when you're looking for a vertex. If you don't see that word, you're just solving the quadratic equation by factoring. And remember, when you are looking for a vertex, all of the scenarios we did were already factored, so that's why I chose to average the zeros. But if you set up an equation and it is not factored, you have to get it into standard form to complete the square. Okay, I want to do one more example here just so that you see when you can't average the zeros. So, two numbers have a sum of 20. The sum of their squares is a minimum. Find the numbers. So I see the word minimum, so I know I'm looking for the vertex. And I have to find two numbers. So for my let statements, let x represent first number, let y represent second number. And now it says that the sum of the numbers is 20. So x plus y is 20. This is clearly not quadratic, so I'm going to isolate for y, and y is 20 minus x. Now here is what we have as a minimum, the sum of their squares. Squares means you're raising it to the power of 2. So we have x squared and y squared. And it says sum, so I'm adding x squared and y squared. And I'll just write that it equals s. So then I'm going to go back and write another let statement. Let s represent sum of squares. Okay, so my only problem here is that I have too many variables. So I'm going to replace y with 20 minus x. And when I do that, I get the sum of the squares, s, is equal to x squared plus 20 minus x squared. This is not factored because we have that addition between those two brackets. This is no longer factored. I can't set s equal to 0 and branch off. So here I am going to have to first get this into standard form, which means I need to write this bracket out twice to do my distribution or my FOIL. And that's super important because I don't want you writing 20 squared minus x squared because that would be completely wrong. So 20 times 20 is 400. 20 times x, negative x times 20, and negative x times negative x is going to be positive x squared. And now I'm just going to collect my like terms to get it into standard form. So I have 2x squares. The negative 20x with the negative 20x is negative 40x, and then that constant of 400. Now I have it in standard form. And now you have the option to either complete the square or factor this first and then average your zeros. I personally, if I have it in standard form, I just jump to completing the square. So I'm going to just finish this question off so that we can refresh on completing the square as well. So step 1 is to factor out just the a value, which is 2, from the first two terms. Now I'm going to take this negative 20 and I'm going to divide it by 2 and square it so that I get negative 10 squared, which is 100. So I'm going to add and subtract 100 to my bracket. Now this negative 100 is useless, so I'm going to multiply it by 2 to kick it out. So that we have negative 200. Now I can finish this off by factoring the perfect square trinomial. So x minus, because of that negative 20, 10 squared. Collect my like terms at the end, and here we are. So that my vertex is positive 10, comma 200. Now look at what equation we had. We had x and s. So the 200 represents that minimum sum of the squares. 10 is x, which is the first number. So my first number is 10, and my second number, we have to use that y equals 20 minus x. So y equals 20 minus 10, which is also 10. So therefore the two numbers would be 10 and 10 to produce this minimum sum of squares. So this is the only type of scenario, if you notice that it's not fully factored, where you have to turn it into standard form first before you choose your method. Otherwise, if it's already factored for you when you're dealing with some sort of area or product or something like that, you can average the zeros to make your life a little easier.